Hi all, Dr. Clark here again. Today we're going to talk about biomes, terrestrial biomes. All right? And we're going to talk about the factors that determine where a biome is distributed on the planet. Talk about some unique biomes and some characteristics of biomes that make them habitats of concern, and so we're just going to introduce them, and then in later lectures when I talk about the tundra, then you'll know kind of a description of what the tundra is. And some of you might already know what the taiga and the tundra and all these other different biomes are, but I just want to make sure that you got the baseline knowledge on the different biomes. Okay? So for example, here's a map of some biomes that would be considered either temperate grassland biomes, where you got short grasses, mixed prairie grass, tall grass in the Midwest, and then maybe shrub steppe or desert land here over in the western part of the United States, including where we're at in Wyoming. But we'll go into a lot more detail in like individual places, okay? Not so much biomes. Today we're just going to talk about the big picture, the biomes, whether it's a grassland, whether it's a desert, whether it's a temperate forest, or whether it's a rainforest, and what are the descriptors that determine that. All right, so first of all, terrestrial biomes. Okay, there are such things as marine biomes, but most of the time they're not called marine biomes or water biomes or aquatic biomes. Most of the time they're called ecosystems. So biomes in general typically just mean the terrestrial environment. Okay? And when we talk about ecosystems that are aquatic, we often put the term ecosystem with it. So marine ecosystems, freshwater ecosystems, lenticolotic ecosystems, which means whether they're flowing or not flowing, the waterways, these kind of things. So in general, though, when someone mentions the term biome, it's talking about the terrestrial environment. So a lot of times I'll just drop the terrestrial part and just say biome. Okay? And so these areas are going to share some kind of climatic data, normally the same kind of temperature profile, same kind of precipitation profile. They're going to have similar soil conditions. That might be soil type, but also like the moisture level in the soils and things like that. And they're going to have similar biological communities, plant communities, animal communities, fungi communities, the whole gamut. But temperature and precipitation are the most important determinants of where a biome is distributed on the planet. Okay? And so when we talk about different biomes, you almost always will see when someone talks about a tropical forest biome and they're giving you information on it, they're going to give you the temperature profile and the precipitation profile, because those are the factors that really determine where the biomes are located and how they're categorized. So if something has a certain amount of rainfall and a certain temperature profile, it's going to be categorized as this biome. So you can look at a map of the biomes, and you can see that the latitudinal bands, most of the time you have similar biomes at each kind of latitudinal band. So like the American deserts and South American or the Central American deserts, okay, they kind of line up in the same plane as the African deserts and the Asian deserts. Now, there are deserts in other places on a different plane, pretty much the exact opposite plane. And you get, your South American deserts more African deserts, and some Australian deserts. Same thing though, if you're going to look at the boreal forest, the tundra, they're going to occur in the same kind of region, as far away from the poles as possible kind of deal. But you will get some examples of, boreal forest and tundra spotted across the landscape, because biomes can also work in an altitude perspective. And we'll talk about this a little bit more, but you can get biomes not only latitudinal across the landscape, but also based on the altitude of mountains or the region or whatever. You can transcend through different biomes. So here you can see, kind of just a generalization of some of the different biomes. Now there are more biomes than this, because some of them have been split, but these are the main biomes where we're talking about the tundra, the boreal forest, these kind of things. And you can classify them via temperature. So tundra, boreal forest, some of the grasslands can be considered cold. Okay? And then, tropical forests, tropical seasonal forests, shrub steppe, woodlands, deserts are often considered hot. Okay? But remember, it's not just temperature profiles. You also have to look at the annual precipitation. So how much rainfall are these, or how much precipitation. It doesn't just have to come in rain. It can come in from snow, rain. It can come in as fog. So a lot of, say, tropical forests and even temperate rainforests, a lot of the moisture that they get is from fog, okay, and not necessarily, rain. It's condensing of fog material, or fog, which is providing a lot of that precipitation. But again, we can classify them with both, okay? So tundra is going to have fairly low amounts of water and be fairly cold. Okay? The desert is going to snake across the bottom. There are cold deserts. Okay? The Great Basin Desert, where the southwestern part of Wyoming is part of it, and portions of Utah, Idaho, Oregon. That's the Great Basin Desert. These are cold deserts. They can get very warm in the summer, but they can get very cold in the winter time, and so that's why they rank as cold deserts. So you get, down here into the 0 range Celsius, freezing, so range. But also deserts can, go all the way up, to the hottest places on the planet. And so we're going to approach these and look at these in a little bit more detail, each one. Okay. And then, like I said before, as you move in altitude, you can also move through different biomes. Okay? Again, biomes are normally predicted by 2 main variables, temperature and precipitation. And as you know, as you move through a vertical zone, from maybe sea level all the way up to 14,000 feet or whatnot, you're going to move through biomes, okay? Because you're going to get different temperature profiles, you're going to get different precipitation profiles. And so you can see, just moving from Fresno, California up to the top of Mount Whitney, you're going to, go from desert in Fresno to grasslands, at the base of the mountains, to oak woodlands right at the base of the mountains. And then as you start transiting up the mountain, Mount Whitney, and these, mountains, part of this cascade system, you're going to start increasing in forest types and changing forests from deciduous forests to coniferous forests, and then on and on and on, until you run out of forest and the trees can't grow anymore, and you get into these small growing alpine tundra plants. And we'll look at this again, especially when we're trying to predict what will happen if climate change continues you probably would expect, at least I would expect, deserts to start moving up the landscape. So maybe deserts are pushing grasslands up, and oaklands are pushing, oak forests up, and oak forests are pushing, because, this whole system is temperature is going to change. With temperature change, you're going to get precipitation changes, and so you can lose the tundra on the top of the mountain and have spruce forests go all the way up. And this is what we've seen in some areas in the United States, but across the world. We've seen the tundra zone either shrink by a lot or disappear completely off some mountains. We'll come back to that later. All right, so tropical rainforests. Let's look at tropical rainforests. Talked about them before. We talked about them when we were talking about complexity of ecosystems and things like that. Tropical rainforests by far are the most species rich and have the highest diversity of species. They're very complex because of the amount of ecological niches. Okay? And part of this has to really do with the nutrient flow. It's a little bit different than some of the other ecosystems. Okay? Now, one thing that makes this ecosystem unique and able to have a high diversity of species is that the temperature is pretty much uniform across the year. And no freezing temperatures, no super burning hot temperatures, and there's an ample or a significant amount of rainfall in these regions. Typically, a surplus of rainfall in these regions. In some cases, it comes, in the form of fog. Okay, so like cloud forests, in say Ecuador, and parts of countries that are really close to the equator, the Congo and things like that. You're going to have a lot of fog that comes into play, and that's where the moisture is coming from. Other tropical rainforests, that are more inland and not that close to the oceans, are going to get it mainly from rainfall, condensation of the rain, and then actual rainfall coming out. And so lots of water, okay, 80 inches or more in a lot of these regions. Okay? That's a huge amount of rainfall. But with that, you can only imagine, or you should be able to imagine, that the more it rains, the less nutrients you're going to have in the soil. Okay? So when these soils are continuously becoming drenched in water, you're going to lose a lot of the nutrients. Okay? So when we look at rainforest, tropical rainforest soils, they are really nutrient poor. Okay? Oftentimes they have a high level of acidity, okay? And that's because rainfall is acid. It's more acidic than freshwater. So, and that has to do with carbon dioxide in the atmosphere being captured by the rain. And so this is one of the main components to climate change, is as we increase the amount of carbon dioxide in the atmosphere, our rainfall is going to become more acidic. And we've seen this many times before we had carbon scrubbers and things like that on factories. Areas around, big cities, the trees would just be deteriorated by acid rainfall. Okay? And so we know about this, and there's lots and lots of evidence for acid rain and the connection between carbon dioxide and acid rain. And we'll go into it later if need be. But nevertheless, so you got a lot of rainfall that's coming down. Soils are, acid soils, nutrient poor. So most of the nutrients is actually in the living organisms. And that's one of the huge benefits about having a high level of biodiversity, is that, lots of organisms in the ecosystem, they play lots of different roles. They're eaten by each other, constantly. So the nutrients can just be tied from one organism to the next, and you don't get as much nutrients bound to the soil. When an organism dies, there's so much diversity in the soil of microbes and things like that, that organism gets recycled very quickly. So what does that mean? It means that we're making a huge mistake in the eyes of most ecologists in cutting down tropical rainforests to plant crops. So rainforest soils are awful, and they just cannot support continual cropping. So the cutting of sugarcane or wheat or corn or whatever grain crop or grass crop we plant in that ecosystem doesn't do very well unless we bring in a lot of nutrients from outside that ecosystem, and we start supplying a lot of fertilizer onto these lands. Because the amount of rainfall, now it grows quick. Okay, so these crops grow quick, and you can probably get 2, 3 harvests, 4 harvests in a year, depending on what the plant is, because there is no cold season, and it's a uniform temperature around throughout the year. It's not quite uniform moisture level, but a lot of times it's pretty close to that, so you can get lots of crops off, but the nutrients are really poor in those ecosystems and need a ton of fertilizer to be able to support crops. Okay? And that's probably the main purpose of deforestation in tropical regions, is really to plant crops. I mean, crops are way more valuable than the rainforest if you're just leaving it there. Economically speaking, way more valuable, at least from the standpoint of money in your pocket today. Okay? It's much more valuable to cut the rainforest down and grow corn or wheat, sugarcane. Okay? Now, what does that do to the ecosystem? What's the cost? What's the cost of water filtration, air pollution, these kind of things? In the end, maybe the rainforest is worth way more than the financial gains you get today by leaving it in place. Okay? We'll look at these. We'll look at what ecosystems are worth. There's lots of papers out there. There's lots of calculations to try to figure out, what's a rainforest worth, what's a wetland worth, from a financial standpoint. Right? A lot of times we don't think about, what they do to clean the air and clean the water. Right? Instead, we think about, well, how much money can we get from the wood, and then when we plant something on there, how much money can we get from that? Okay? And we'll come back to this. It's a real world issue that we need to look at in much greater detail. But like I've said before, about at least half the terrestrial organisms on this planet live in regions that we classify as being tropical rainforests. It's probably even more than that. The issue is we haven't identified all the organisms, so we don't know how many organisms live in the tropical rainforest. We don't know how many organisms live in really any ecosystem, because we haven't classified them all. And so, but it's probably half to probably less than 2/3, but it's most likely more than a half. All right, so let's look at tropical rainforests. If you're really interested in tropical rainforests, maybe you've seen the video on the Galapagos trip. Again, I'm leading a Galapagos trip in May. We'll go to a rainforest in Ecuador, and you can check it out if you've never been to one. They're amazing. Amazing ecosystems, amazing diversity, and it's a travesty to see that they're being cut down. But at any rate, look at this temperature profile of tropical rainforests. Man, I mean, you're looking at about 28 degrees Celsius year-round. That is really constant temperature. Now, your precipitation is a little bit different, but you can see that if it's blue, okay, and above the line, you get a surplus of moisture. So these ecosystems always have enough water. Okay? And so it makes it so, they have a very constant temperature, fairly constant precipitation, so they can get constant growth rates from the plants, and that, you know, just continues with constant growth rates for the animals, and on and on and on. Now, to also kind of combine that to another type of rainforest, which we call the temperate rainforest, very similar ecosystems, right? But temperate rainforests are often, well, they're in temperate zones. They're away from the equator, right? And they occur where, most often, where there's lots of moisture from, the ocean. So, Pacific Northwest, Washington, Oregon, Northern California, that's where you're going to find, temperate rainforests. Canada, the western part of Canada, you're going to find these temperate rainforests. Okay? They're very similar, but you can see that the temperature profile can be a little bit different. Okay? You can get months in which you can have freezing, and you get a little bit different in the precipitation, where you can have drought periods. Okay? A little bit different, so you get a little bit different diversity of plants and things like that. Nonetheless, they're still considered rainforests. All right, tropical savannas, grasslands. Okay, they're normally distinguished, from a plant community point of view by not having very many trees. Right? And that really has to do with a lack of rainfall. The rain just doesn't support trees that, or forests and things like that, that grow year round and stay on the landscape for a long period of time. The rain comes, sporadically, and will support a lot of annuals. So things like grasses that will just sprout, go to seed, die, sprout, go to seed, die, and on and on and on after, the rainy season. Okay? But because of that sprout, go to seed, die, these areas have really deep soils, very rich soils when it comes to nutrient loads and things like that. So great areas to grow crops. We know this because we plowed up almost all the grasslands in the United States, kind of the Midwestern part of the United States. Almost all the prairies have been plowed up, and we grow majority of our food in these regions. Right? So you can, there's good and bad with that, of course. You don't have very many native grasslands left, but we also have areas which we grow food that supports, the 350 million people that live in the United States, and then even more people, foreign countries and things like that that we trade with. Okay, so the savanna can be tropical. Okay, so you can look at the same kind of zone, and you'll see, in Africa and India, you can see tropical zones, a little bit of forested habitat, but mostly grasslands. Okay, and you can see here, you get, temperatures that are pretty stable, okay? Not freezing, okay? But precipitation can go from, none for quite a few months to a massive amount in the rainy season to none again for quite a few months. Right? And so it's that flux in precip that allows for grasses to grow, but prevents a lot of forested habitat. All right, deserts. Most of us know a lot about deserts because if you live in the western part of the United States, you encounter deserts on a daily basis. They are characterized mainly by low moisture levels, less than 30 centimeters per year. Most deserts actually have less than 10. And so it really just depends on the year. And, most of us who live in this region, we know that, okay? Because some years you can have, ton of rainfall and you have big wildflower blooms, and then you might go a couple years where you're sitting in a drought and there's really no rainfall or no snowfall, and you're way less than that 30 centimeters um, per year. The other thing that most deserts have is a very wide fluctuation of temperatures. Okay? So it's not this stable temperature, and that can be true for seasonal across the year temperatures, but it's also true for daily temperatures. You get a huge flux. It might be super hot during the day and cold at night, and so you get these influxes of temperature that can cause most organisms to be stressed out. And a lot of organisms, and we'll talk more about adaptation as we progress, but a lot of organisms have adapted to this environment. Okay? So they might have a cuticle layer or thick epidermis if you're talking about plants, and they have this waxy layer that goes over the top that prevents them from taking in too much UV radiation and losing a bunch of water and whatnot. Now, a lot like the grasslands and the savannas, okay, blooms come when rains come, and if no rainfall comes and there's a lack of rainfall, then plants don't bloom, plants don't even germinate, and so you can have huge wildflower blooms certain years, and then other times there's nothing. And we've talked about adaptations before because we talked about evolution, ecosystems, things like that. All these environments have organisms that have adapted to that biome, but the desert one has some of the most unique adaptations, mainly because the adaptations are so different than some of the other adaptations that we see. Things like, being majority of your organisms being nocturnal. Okay? Some of the organisms being able to conserve water to the point where they don't even drink. Okay? So they never drink in their entire life. We're talking about things like kangaroo rats and certain types of desert beetles that they never ever consume water. Okay? They get all the moisture they need from seeds and things like that, and they just have a way to conserve moisture in their body. And there's lots of adaptations to that. Now, one of the things that I often talk about when we talk about deserts, and I talk about this mainly because we live in a desert in this region, okay, and I live in a desert, so I talk a little bit more about deserts than some of the other ecosystems, but deserts are very vulnerable to destruction, okay, and destruction from lots of things, okay, whether that be off-road vehicles, whether that be like, plowing of the sagebrush or desert environment. It takes so long for that environment to come back because there's so little moisture that environment could sit without a plant community on it for 10, 15, 20, 30, 50 years even. Okay? I mean, for example, if you go to the South Pass, you can still see where the Oregon Trail went across South Pass and went across our landscape. You can still see the tracks, and I mean, they're blatant tracks. You can see these tracks. You know that they're wagon wheel tracks based on the width of the track, and I don't know what the last time someone traveled on that in a wagon, but it started in about 1830. Right, so we're talking, not quite 200 years, but 180 years later, and you can still see the divots from the wagons. And yes, it was a different type of vehicle and things like that, and they were all traveling on the same tracks and things like that for many years, but it doesn't matter. This ecosystem is not going to rebound. You'll probably be able to see those tracks for another 100 years. And that really is because the soils, they don't rebound very fast. And and the vegetation doesn't come back because there's really no moisture for them to grow. Okay? And so we see issues with this when we talk about overgrazing in certain regions, talk about off-road vehicles, we talk about, you know, dredging areas to either put a platform for something like a wind turbine, or plowing it all over to put solar panels, or, you know, making a bunch of roads to oil wells, natural gas wells, and well pads and things like that. This vegetation is not coming back, right? And it takes forever for that vegetation to come back. So here you can see a desert, never surplus in moisture. Okay, that's one of the key things with deserts. There's not going to be a surplus in moisture. Temperature is, profile is very variable across the year, and depending on the desert. So this is considering a hot desert, because cold deserts, they dip down to zero in a lot of the months, as you would know if you're, living in a cold desert. But same deal, you're still not going to have much of a surplus of moisture no matter what desert you're in. Okay. Temperate grasslands. Okay. Again, whether we're talking about savannas and grasslands, the temperate grasslands are kind of much the same kind of thing. Very few trees due to the lack of consistent rainfall. Okay. You can get daily and seasonal temperature fluxes that rival kind of desert regions, but it's dominated by grasses and seasonal plants. Okay. Again, just like the tropical grasslands or the savannas, or you're going to have very thick organic soils from a lot of grasses dying and rebuilding your soils quickly. And I kind of already hinted on this. The temperate grasslands have been plowed over for U.S. farms, but the African grasslands a lot of them have been plowed over. Okay? The Asian grasslands or grasslands that occur in India have been plowed over. So it doesn't really matter if we call it a tropical grassland or a temperate grassland. If it's a grassland, it means that the soil is thick and high level organic, excellent growing media. Okay, and we figured this out a long time ago and have utilized it for the benefit of humans. So here you can see a little more flex in the temperature than those savanna grasslands and the tropical grasslands, but again, you get these moisture profiles where you can get surplus of moisture throughout the year. Sometimes a lot less moisture, and then sometimes a heavy amount of moisture, which can drive high blooming of grasslands and things like that. Temperate deciduous forests, a lot of deciduous forests. So deciduous trees are trees that lose their leaves, and we have a pretty, I guess you could say, nasty history with deciduous trees in the United States, because they were excellent for lumber and they were excellent for heating your homes and things like that. Pretty much the entire eastern half of the United States, when settlers arrived to the United States, was deforested. Okay? Every single tree was clear cut and cut down. Okay? Now, since then, a lot of trees have been replenished and replanted. Okay? And you have quite a few healthy forests, but you have no original forest pretty much anywhere in the eastern United States, except for maybe the Appalachian Trail. You have some there, and some in like Maine. There's some places where there's some forest left, and some parks and things like that might have trees that were never cut, but majority of trees were removed, harvested from the landscape when settlers came here. Now, the trees that are regrown are a lot of trees that do not, they're not native to the United States. Okay, so Chinese elms and other trees that we got from other countries that grow fast, and can replenish the landscape. But the trees that were once here are now all gone, and the landscape that does have trees are typically trees that are not native to the landscape. There's a lot of other temperate deciduous forests and places, Russian forests, Siberian forests that have high levels of deforestation because hardwoods or deciduous forests. Hardwoods make really good lumber. They make a good wood for building things that you want to last for a long period of time. Better than coniferous forests. Coniferous forests, like pines and firs and things like that, the wood is not as good if you want the material to last for a long time. So here you can see some temperate forests. Again, temperature profiles, fairly heavy flex of temperature profiles, but these regions are going to have surplus of water, and that's why you can have forested habitats. All right, boreal forests. The boreal forests occur between about 50 degrees and 60 degrees north latitude. Now, that's true from a latitude point of view, but you can also see boreal forests as you move up in altitude on different mountains. Okay, so you can get, even, in the state of Wyoming and Utah, Idaho, Montana, as you move up our mountain landscape, you can go from, being dominated by things like aspen, things like that, into domination of pines and spruces and firs as you move up the mountain. The taiga is, at the very edge of the boreal forest, so typically, above 60 degrees north latitude, okay, or, above the level on a mountain. Okay? The growing season is extremely short in these regions, so really cool situation where you can go to some of these regions in taiga, and you can find a tree that's got a trunk about yay big, and if you're to core that, and I'll talk about coring later and show you kind of the process of coring, but if you take a core out of that and read the growth rings, that tree might be 200 years old and this big. An aspen that big, maybe 4 years old, okay, 5 years old, in a good habitat. So you're talking 200 years to get 4 inches in diameter in some of these regions, and that's because very short summers and extremely long winters. So here you can see the boreal forest. Okay, massive temperature flux. Okay, very few days out of the year where you're not freezing. Okay? And there is a lot of moisture, okay, that can be built up on the landscape, but the growing season isn't very long, so trees typically are shorter and don't grow as fast as some other plants. And then the tundra, there really is no trees. Okay, so the taiga is going to have some trees, so it's going to go boreal forest, taiga, and then tundra. And the taiga is going to be kind of a transition between the boreal forest and the tundra. And the tundra is pretty much, never warm enough to melt the ice, so it almost always has what we call permafrost. And so the ground's almost always frozen in some, or has ice crystals in some form. And so there's very few months where it's above freezing. There is moisture in this region, sometimes a surplus of moisture, but then again, it doesn't really matter because the plants don't have much of a growing season, so you're not going to find trees and things like that in this ecosystem. Okay, so that's just kind of in a nutshell the different biomes, terrestrial biomes on the planet. Now, I skipped a few, okay, like the chaparral and some things like this, mainly because they're just sub-biomes of another biome. And so I skipped over them just for convenience of time. If we talk about like the chaparral in California and things like that, I'll bring in a temperature profile so you can check it out. But it's it's very similar to temperate grasslands and whatnot. Okay, so next time we're going to talk about marine ecosystems and freshwater ecosystems. So till next time.